Okay, so example 3, rational expression with pairs of non-permissible values. Okay, so we're going to take a look at an example where our denominator has two variables. We're going to do two things. The first one, what expression represents the non-permissible values for x? Okay, now you can find the non-permissible values for y too, but we'll work with x. Then we're going to simplify the rational expression, and then we'll evaluate for x equals 2.6 and y equals negative 1.2 and show two ways to determine the answer. So to start with, let's take a look at our non-permissible values for x. So our denominator is 8x minus 6y, and we want to make that equal to 0 and solve for x because we want non-permissible values for x. And we get that x is equal to 6y over 8, which reduces to 3 over 4y. So x is equal to 3 over 4y is our non-permissible value. Okay, so this means that when x equals 3 over 4y, the values for x and y that make the statement true are non-permissible. So let's try one example to show that this is true. So let's say that y equals 1. Okay, I just chose that number. I could pick any y value. And I plug it in. Then it gets simplified to x is equal to 3 over 4. And so we have an ordered pair, which is x is 3 over 4 and y is 1. So that means that when x is 3 over 4 and y is 1, the expression is undefined. Okay, actually in this case it's indeterminate. I'll show you what that means in a moment. But what it means is that when x is 3 over 4 and y is 1, together they're non-permissible. Okay, so let's just show you that. We're going to plug in to the original expression. X is 3 over 4, so we're going to go 16 times 3 over 4 squared minus 9 times 1 squared over 8 times 3 over 4 minus 6 times 1. And when we simplify the numerator and the denominator, we get 0 over 0. Okay, now when you get 0 divided by 0, it's considered indeterminate. Okay, and indeterminate means it has no meaningful value, or if you like, it's not a number. Okay, so what I've shown you is that when x is equal to 3 over 4y, okay, and I just picked a number y equals 1, plugged it in, got a coordinate of 3 over 4 and 1. It means that when I plug those numbers into the original expression, I get 0 over 0 in this case, right, which means that it's indeterminate, has no meaningful value, it's not a number. And so when x is 3 over 4 and y equals 1, we consider that non-permissible, okay, because it doesn't work out. I just showed you that right here. Okay. All right, so let's move on to B. You've been asked to simplify the rational expression, so I'll just rewrite it. So you have 16x squared minus 9y squared over 8x minus 6y. Notice that the numerator is a difference of squares, so we're going to factor that into a sum and difference. So we get 4x, 9y, 1 bracket's plus, 1 is minus. And in the denominator, notice that you have a GCF of 2, so you're left with 4x minus 3y. Oh, these should be 3, sorry. Square root of 9 is 3. Okay, and you can reduce. Okay, so that 4x minus 3y goes into itself once, and our final simplified answer is 4x plus 3y over 2, where x can't be equal to 3 over 4y. Okay, part C. Check that the values x equals 2.6 and y equals negative 1.2 are permissible. So the first thing that we want to do is we want to check to see if we can use those numbers. Okay, so we write down our non-permissible value. Okay, so x is 2.6, and then plug in y is negative 1.2. Okay, and simplify the left and the right. So the left is already simplified. When I go 3 over 4 times negative 1.2, I get negative 0.9. Okay, notice they're not equal to each other, so the left side does not equal the right side. That's okay, because recall that when x is equal to 3 over 4y, the values for x and y are non-permissible. Okay, so we've shown that the left side doesn't equal the right side, so that's okay. Okay, so thus x cannot equal 3 over 4y, or does not equal 3 over 4y for x equals 2.6 and y equals negative 1.2. So these values are permissible. Okay, so we are going to do the second part of this third part, which is to show 2 ways to determine an answer. Okay, on the first one, we're going to start with the original rational expression, okay, which is 16x squared minus 9y squared over 8x minus 6y. And I'm going to plug in x is 2.6 and y is negative 1.2. So I'm going to get 16 times 2.6 squared minus 9 times negative 1.2 squared all over 8 times 2.6 minus 6 times negative 1.2. And when I simplify all of that, I get 3.4. Okay, the second way that I can evaluate, okay, is to plug into our simplified expression, which is 4x plus 3y over 2. So I'm going to go 4 times 2.6 plus 3 times negative 1.2 all over 2, and when I simplify that, I also get 3.4. So notice I get the same answer regardless of which expression I use. Okay, so you want to choose the one that you think is best. For sure, if you use the original expression, you should get a good answer, right one anyway, because less opportunity to make a mistake, because possibly you might have made one on the second one. Okay, But of course, the second one is easier to simplify, so you may choose that one. Okay, and that's it for today.